Today's lesson is a continuation of section 3.1, solving one-step equations. Today I'm going to show you a little trick we can use with fractions when we have those in an equation and we're trying to solve and get the variable by itself, but we're presented with some kind of fraction that's maybe multiplied to the variable or on that same side of the variable. There is two good ways you can probably deal with it. One way, as I'm sure students have done in the past, and probably kind of have figured out as well, is you can always turn a fraction into a decimal and solve it that way. And I'm going to show you another method to use though without going right to the calculator, not being so dependent on that. But here is the first way. Is let's say we have an equation like 1/2 times x equals 10. Well, again, 1/2, that fraction, can actually just be converted to this decimal, 0.5. If I take 1 divided by 2, that's what I get in the calculator, 0.5. So I could rewrite this as 0.5x instead, equals 10. And then show in steps like we did in the previous lesson. If I just divide both sides by 0.5, that will get rid of the 0.5s on the left side. So I'll just have x by itself, which again, that's what I'm trying to do. I'm trying to isolate the variable, get x by itself. That's how I solve an equation. And then on the other side, 10 divided by 0.5 would give me 20. So that's one way you could deal with these problems. If you have a fraction that's the coefficient of the variable, or it's multiplied next to the variable like that, we see this every once in a while. This is one way you could deal with it. You could change it into a decimal. But I'm going to show us another little trick that you could use as well. So again, you don't have to necessarily go right to the calculator. And it does teach us something about fractions, or something that we should know and maybe could figure out as we go here. It's another way I could solve these particular equations that have a fraction in them. Think about a problem like this, where I have 5 divided by 2 times 12. So this fraction, 5 halves times 12. If you were going to multiply and find the answer to this problem, well, what I could do is, remember when we're multiplying a fraction times a number, sometimes it helps to see what we have to do by having both numbers in fraction form. So how do I write 12 in fraction form? Well, that's just like putting 12 over 1. So I'm going to rewrite this now, just to show everything kind of lined up nicely. 5 over 2 times 12 over 1, if I was going to multiply these two numbers in fraction form together. And how do I multiply two fractions together? Well, all I do is I just multiply the numerators together and multiply the denominators together. So I multiply across the top and bottom, and that'll give you my answer. So 5 times 12 gives me 60. 2 times 1 gives me 2. And 60 divided by 2 gives me 30. But here's more what I want us to realize. Is so what happened here back from the original problem. When I had 5 divided by 2, when I have 5 halves, that fraction, times 12, what number did I actually end up multiplying the 12 by? I ended up multiplying it by the top number. And that's what's always going to happen if you have some kind of whole number that are sitting by itself multiplied to a fraction, is I'll end up multiplying that number times the top number. Well, how does that help us? Again, in the problem, in the equation above, we had a fraction times a variable. So maybe something like this we could see in an equation in the future. 5 halves times x. Well, what I'm telling you is, if you notice from the top problem, top example, is that whenever I have a fraction times some kind of whole number, or sometimes some number sitting there by itself, what ends up happening is I take that number and multiply it by the top number of the fraction. That's the way it'll work. I could rewrite it in fraction form again to show it. 5 over 2 times, well, we could just put this as x over 1. And again, what I'd have is 5x. 5 times x would give me 5x. 2 times 1 would give me 2. So yeah, I'd still just get 5x over 2. But I guess the shortcut way I'm telling you is that if you have a variable times a fraction, then I can just multiply that variable times the top number and rewrite it like that. That'll help us in an equation, because now as opposed to changing that fraction into a decimal and just having to go right to my calculator and try to figure out the answer, well, instead I don't have to be so dependent on my calculator. If I see that this term right here has a fraction as its coefficient, and that means a fraction times this variable here, x times x, what I can do is let's rewrite this just like I showed above. Let's just put that x with the top number. So now I'm going to rewrite this instead as 2x divided by 3 equals 24. This is still the same problem. I haven't changed anything. I've just put the variable with the top number, which is, again, if I multiplied those, that's really what would happen anyway. Well, now, if I have 2x divided by 3 equals 24, we can use some steps like we learned yesterday for solving equations And this will still be something we could solve without necessarily going right to our calculator and making some kind of decimal number. So it can be an easier way to solve this problem. I'm going to draw my line, as I've talked about in the past. And that'll remind me that whatever I do on one side of the equation, I have to do on the other when I'm solving. I'm trying to get x by itself, this variable right here. So what do I notice is happening? Well, they're multiplying it by 2, and they're dividing by 3. So what do I do? Again, to solve, I'm going to look to do the inverse of those operations. If they're dividing by 3, what I'm going to do instead is I'm going to multiply both sides by 3. That's going to help me get this variable, solve this equation, get the variable by itself on the left side. When I multiply both sides by 3, it'll cancel out these 3's. So now what's left on the left side is just this 2x. I'm going to bring this down to my next step. 2x. And 24 times 3 gives me 72. Now I've just got it down to a one-step problem, which is like what we worked on the previous lesson. Still in this section. Divide both sides by 2. X is going to equal 36. So again, this is just I'm just showing you another way. When we have a fraction in the problem, we don't necessarily have to run right to our calculator and change it into a decimal and then solve the equation. Okay, we can still do something with this fraction. There's a way to work with that fraction where I can still get a nice answer, and I don't have to be working with decimals all the time. I'll just go through another couple examples here. This one also. Again, so kind of like we've seen already for a problem. This is 2/3 x equals 14. So I've got a fraction here multiplied to some number, in this case a variable. And it wouldn't matter if that was a number or a variable. I'm telling you this the same way like I showed you on that first page, is that means that this variable is really multiplied to the top number is what's going to happen. So I'm going to rewrite it like that. I'm going to write it as 2 times x divided by 3, and that now equals 14. Once I've rewritten it, and I have that down here, 2x divided by 3 equals 14, now I can solve it again using steps like we've learned. I'm trying to isolate the variable, get x by itself. Well, again, what's happening with the variable? When it's right next to this 2, that means they're multiplying it by 2, whatever that number is. And when it's divided by 3, that means they're going to divide whatever that is by 3. So I'm going to look to do the inverse of those two things. I'm going to multiply by 3, and I'm going to divide by 2. Those are the steps that are going to help me solve this equation. First, we'll do the dividing. Sorry, we'll deal with the dividing. They're dividing by 3, so I'm going to multiply by 3. So if I multiply both sides by 3, these 3's will cancel out for me. All I have left on this side is 2x. So 2x equals, well in this case 14 times 3 on the other side, that gives me 42. And now if I just divide both sides by 2, I'm going to get x equals 21. Showing one last example just to make sure we got it. This one says 4/5 x equals 16. So again, one way I could deal with this is I could just take 4 divided by 5 and turn that into a decimal, and it'd be 0.8. And I could say 0.8x equals 16 and divide both sides by 0.8. And that would work. That would give me the answer. But I'm showing you here's another way you could do it. If you have a fraction in a problem, you don't necessarily have to go right to your calculator. What I can do is I can say, well, when this fraction is multiplied times this variable, or times any number really, what's going to happen is that x is going to be multiplied times the top number. So I'm just going to multiply it times the top number right now and rewrite it like that. 4x divided by 5 equals 16. Once I've rewritten like that, I'm going to use steps that we know how to use for solving equations, and I'm going to isolate x and get it by itself. So they're multiplying the variable times 4, and they're dividing it by 5. I'm going to do the inverse of both those things. So first, I'm going to start off by multiplying this equation by 5 to both sides. Whatever I do to one side in an equation, I have to do to the other. So if I multiply both sides by 5, I clear the 5's out on the left side. All I've got left on this side still is the 4x. That's going to equal 80. And now when I divide both sides by 4, I get x equals 20. Again, this is just a nice trick when we have an equation that has a fraction. Okay, we can still solve any other equation normally like we had from the previous lesson from 3.1. If I still see a problem like 8x equals 24, I don't have to change everything into a fraction or do anything different. I can just divide both sides by 8 and get x equals 3. That'd be the solution for that problem I just made up right there. But if we do have a fraction in the problem, this is another way we can deal with it. I can write that variable on the top of the fraction and then still also use inverse operations to solve and get x by itself.